Welcome to Study Physics. So our next problem is of 50th problem from chapter 12 only. So in the 50th problem, what is asked is a uniform disk of radius r is to be suspended through a small hole made in the disk. Find the minimum possible time period of the disk for small oscillations. What should be the distance of the hole from the center for it to have a minimum time period? So in this problem, what is given is we have a disk, so we have to first consider a disk. So just consider this is a disk. So for disk we have considered, and we know that for disk and ring, so ring only the mass is at the peripheral point, but for the disk mass is just everywhere. So in this part also the mass is distributed, and for the case of ring the mass distributed is only over the peripheral point. So fine. So now if we consider the central point at this particular position, by that time, since we are required about the time period, so we need the value of moment of inertia. So in this problem we are asked that we have to consider some point inside the disk where we have to just consider that we have fixed the disk there. So and through this particular point we have to first evaluate the value of time period for this disk for a simple harmonic motion, and then we have to find the minimum value of the value of x for which the time period will be minimum. So just consider that from the central point we have considered a point at a distance of x from the center. So we have considered like this. Now this is our point of suspension, and with this point of suspension we have to find the value of time period such that it should be minimum for any value of x. So like that we have to evaluate. So just for this problem, if we have to evaluate the value of moment of inertia, so for the first case we will evaluate the moment of inertia about the center of mass. So for the disk, moment of inertia about the center of mass will be mr square by 2. So if the radius of this disk is r, by that time moment of inertia about the central point will be mr square by 2. So this will be the moment of inertia about the central point. So fine. But again for this problem we not require the moment of inertia about the central point, rather we require the moment of inertia about our fixed point. By that time the moment of inertia will be mr square by 2 plus of m, and distance is x, so just x, and square that term. So we got the moment of inertia about our fixed point. So now we have to evaluate the time period for this particular moment of inertia. By that time the time period will be 2 pi under root I by mg, and distance between the center to the point of suspension, so that is our x only. So we can simplify a bit more the moment of inertia, because it will help us. So mr square, so this is just r square plus of 2m x square by 2 it will be. So we can write the moment of inertia like 2 pi under root mr square plus 2m x square divided by 2mg into x. So it will be like m term will be cancelled. So time period can be written as, so r square plus of 2x square divided by 2gx. So this is the equation for moment of inertia for considered point. Now we can write like t square will be, So t square will be 2 pi, and this term will be r square divided by 2x square upon 2gx. So in order to evaluate the minimum time period, what we should do is we should differentiate the time period with respect to x and then equate it to 0, so that we can find the value of x at which the time period is minimum. So for that case we can also do like d2 means dt is differentiation of t square with respect to x equals to 0. It will be same like this value only. So we will do it for t square. So now dt by dx value, or dt square by dx value will be, so here we can write it like 2 pi r square divided by 2gx plus of, here it is 4 pi x square divided by 2gx. So 2 value cancelled, again here 2 will be there only. So this can be written as, so here it is just pi r square by g into 1 upon x, plus here we can write as 2 pi gx. So now if we differentiate this term, so if we differentiate this term with respect to dx, so we have to differentiate this term with respect to dx. By that time what we will be getting is this term will be like pi r square g, and there will be one minus term, and then it will be 1 upon x square, and this term will be 2 pi g value only. So now we have to equate this value equals to 0. So then we will be getting the value of x here. So what we can do here is a g value will be cancelled, pi value will be cancelled. So what we can write is r square upon x square will be equals to 2. By that time, if required the value of x, by that time x square will be r square upon 2. So value of x will be r upon root 2. So this is the position, or this is the location where the time period will be minimum. So this is part B of our answer. We have to go like this only. We have to first solve for the part B only, and only then we can solve for part A. So now if we put the value of x is equals to r by 2, by that time we can evaluate the minimum time period value. So if we consider this equation as a 1 and consider this equation like 2, so after substituting equation 2 in 1, we can evaluate the minimum time period value. So let me write that value first, and then we will substitute it. So this is like 2 pi, so we have to just copy. So 2 pi under root, so it is 2 pi under root r square plus 2x square, r square plus 2x square. So it is like r square plus 2x square divided by 2gx. So it is 2gx, so we have to write like 2gx. So 2gx. So the value for t minimum will be 2 pi under root r square plus of 2. At the place of x square we can write r square by 2, and in the denominator part it will be 2g and r by root 2. So this value will be written like root 2 only. So it will be 2 pi under root, this term will be cancelled, so 2 r square divided by root 2 gr. So r value will be cancelled. So t minimum value will be 2 pi under root, this value is root 2r by g. So this should be the value for t minimum. So let us match the answer first. So this is the 50th problem, so it will be 2 pi under root 2r divided by g. So this is the solution for 50th problem. So in this way we solved our problem 50th. So thank you.